Gentlemen, and I think it's always has a lag time, so I'm probably going to say that again. Hello, ladies and gentlemen. All right, and haters alike. We'll have a little fun on this Tower Bridge. Not today, but I want to use this to start off with about tension and compression, things like that. So is this bar, this appears to be a coupling, is this bar in tension or is it in compression? What would you guys say it is? Well, if this was falling down onto this deck, that would be in compression. But we have no evidence of it falling down, so it appears to be anchored at the tower, and therefore this would be a tension bar. It may be zero if the span of these joists and the load applied to them can take without deflection, could take the span where it rests on the supports here and at the next tower, at the next location. So is this a tower it rests on, or is it a pier? It's a pier here, the whole assembly's a tower, and this is where it's anchored at that point. So is it tied across? We'll get to that in another video. This video is about something as simple as this guy. If you ever guys watch this Jimbo's Garage, I have envy of his garage. I do not have envy of his skills, but I have envy of his garage. I have envy of his channel also, if we're going to talk about it. He's doing great with there. And, he's an older guy, so I support that too. Now, he totally misses what's going wrong with this. And this is the problem with a lot of contractors, that they think they figured out what the simple problem is that this bracket is too small. It's supposed to be 6 inches bigger or whatever he says. Let's dive into that. So I do critique some of his welding skills also. I mean, he'll grind a weld off down to flat without beveling. He'll just weld into here and then he'll belt, because he likes the way it looks, it'll go flat. Like right here, for example. He didn't do this. I don't think he did this gate, but he'll bevel it, he'll plane it flat, and yet the bevel didn't take place to get a good root pass, if you will. But based on the loads that's on, it possibly might be okay. Let's talk about what you observe already in this image, is my beautiful 45 right here in a beautiful, another break this direction. Damn it. I'm going to add another part to this video. You guys have a stone video. I was showing you how to break stone and how beautiful it is. Damn it, that's really kind of critical to this. Maybe I can find how to fracture stone. How to break stone, and let's see if it comes up on it like that. Videos. With wedges. Wedges. All right, let's do that. So it lets you guys walk your way into it. So here are the wedges. Trowel. That's a good company. I have a bunch of wedges. I love stone and all that. It's only minute 34. That's beautiful. Let's pause this volume. We don't need their narrative. And let's just jump to it. So these are the wedges. He's showing a keyway, a bunch of wedges, larger, smaller, and sometimes you go to 4 times as much the depth. So if your stone was 12 inches, you would need like a 3-inch wedge to do it, typically. And you drill the hole, and then you put these inside the hole, and then you drive these wedges down, and it'll cause a fracture in the stone. You drive them all down. There's a series of holes that would be next to each other that you would drive them. Oh, there we go, like that. Let's see. Let's just fast forward it. Oh, yeah, there he goes. So he's tapping them in. He's probably sounding them, feeling which one's more solid than next, because it appears to be a little random with his banging. Oh, he starts in the beginning. Okay, there we go. So there's a wedge. It's kind of important. And it's putting stress in the stone. Let's stop there. So even though you can't see it, that stress is put into that stone right now. It's in there. It's part of the stone. Based on just these pieces of steel pins sticking up. This is why all this stuff matters. Now, I'm going to show you the failure of what's really going on with that gate. Come on, let's see him break the stone. Clearly there's no intention not to break it. There you go. There's a fracture right there. And it came from there to there. It's in line, it's controlled, it's stressing, pushing this side out, pushing this side out, and this side out, and that side out. And these stresses can see each other, if you will. That's why you get such a more clean line. It's a good company. I've purchased from them. Well, their product is good. Let me put it that way. I don't know about the company themselves. Oh, beautiful. There we go. Oh, he's trying to pull it apart. Oh, yeah, he just did. Oh, this is beautiful. This is perfect. Notice that's the depth of his drill. And then those wedges continue the rest of the break right there. See the clean break? See the clean break. Now let's go back here. Let's get back to the video. Again, so this is not an attack of this guy's channel. It's an attack of he's missing what's going on, you know, the skill set. Looks like I had this ready primed, so it's
clearly see that okay. It appears that around to the other way, down the sun, that this bracket is broken off the concrete column.
Hold on, let me take a drink here. New Year's. All right. So what do you observe? You see a solid piece of concrete broken off. You observe hole in hole, and you see what appears to be bolt holes. So is it a bolt or is it a screw? All right. Those are not.
It looks like it may have happened a couple of times. It looks like a repair job.
It looks like it. So he's making analysis,
down
you know,
there.
data.
So I think what the goal is here is to make more of a bigger bracket. I'm not certain what I'm going to do. Probably get a big old piece of angle iron. I don't know, maybe a foot or so big, maybe some 6-inch, 5-inch, or 6-inch angle. Wrap the corner, put a couple, 8 bolts in there, and hopefully that will solve the problem. Go ahead and fabricate a bracket very similar to what's right here.
So he believes it's more bolts. More the bolts, the merrier. Now I just showed you what's going to happen when you add more bolts, specifically close together. You're creating a pattern, a path, depending on how your bolts act. This is what I'm sharing in this video. Are your bolts acting as a bolt, a clamping force, or are they also acting as a wedge? Now, this was, so imagine the forces here. This gate goes to close. Oh, I guess I should have shown you the gate from here. Okay. So here's the gate from here. That's that clamp we're looking at. That's the gate. So you can see it, the hinges are working great. Apparently they're pretty plumb. This gate appears to be plumb and level. Appearances. And yet the hinge is breaking. This closure is ripping off the back side only of this, not once but twice. Apparently twice, as he stated. Well, I don't see they must have did some nice weld job down here because I don't see where it would connect. I see it connecting here, and it appears not quite to be in plumb with in line with the clamp or the clamping area, which is up here following this bar down. This appears to be lower. Just appears in this image. Doesn't mean it's true, because he's on a hill there, and I could be getting thrown.
Right here. So let's go up and take a look at it and see what's going on.
Okay, so right about, I'm trying to keep this hinge connection here, the bolted connection here. All right. So it appears that might be a slight bit lower if you use this axis right here and you line it up. I'm seeing it visually as right about there. And then as the gate swings open, it should be plumb. So this should be level, rather, with this whole system. So if he was to close this, would it land naturally here and then flexed up? It would be there. So that creates a torque action on that bolted system, which would also explain the fracturing. But let's go with, yeah, I would say it's low. I don't know about you guys. It appears if I swing this around that I would be low on the connection.
You can clearly see that it appears that around to the other way, down the sun, that this bracket is broken off
So what do we have? We have 2 holes in proximity to each other, which you're starting to create that fracture in the stone I told you. Also, I'll cut to the chase. We have a soft-looking mortar mix here. Very soft, very airish. Look at it. Full of air. So it's just full of voids ready to split.
The concrete column. And it looks like it may have happened a couple of times. It looks like a repair job down there. So I think what the goal is here is to make more of a bigger bracket. I'm not certain what I'm going to do. Probably get a big old piece of angle iron.
I want you guys to see this
I don't
part
know,
here.
maybe a foot or so big, maybe
This
some
is the critical
6
part
inch,
coming
5 inch, or 6 inch angle. Wrap the corner, put a couple.
You can see his full video here. He's
8
actually fun
bolts
to
in
watch.
there.
I haven't watched him in a while. I tapped out. You know how you watch somebody so much and you finally like, he had enough. Well, I enjoy his table and everything else. And it's soothing. I listen to a lot of things. I listen to War.
And hopefully
World War
that
II, World War I.
will solve the problem.
World War II
Go
is my
ahead and
favorite.
fabricate a bracket very similar to what's right here.
He's going to fabricate a backer. I'm going to cut to the chase. Why doesn't he just weld? He's a welder. Weld on top of this, the extension. 6 inches that way, 6 inches that way, whatever he wants, so a total of 6. He's going to, this is the part where I take offense. So this is my thing. He's going to fabricate this thing from scratch. Well, I don't see a broken bracket here or anything else. Why wouldn't you just weld to it? And that will tie into the video I'm going to show you in a moment. What I'm talking about, just repairing welds instead of throwing away the whole thing. Of course, it appears to be more money in doing the entire thing than fixing it with welding.
Take care of the problem. So let me get some measurements, figure out the material I'm going to use, try to figure out how I'm going to do this. And let's get back to the shop.
Hold on, guys.
Start today's video.
He's going to take it apart. I want you to see that. I didn't know. We got.
Okay, so what I'm actually going to do is I'm going to go ahead and take this bracket off and bring it back with me to the shop. This is what I need him to
see because he's going to show us data here.
Unfortunately, I can't do this. I'm not going to be able to film taking this off because this is a...
He's not going to be a film taking off, but yet he pulls it off and he shows a loose screw here that he can turn with his finger. I sort of jumped through the video a little bit, but I'm trying to get to a part I want to show you. Hold on. So bear with it. I'm fast forwarding. Okay, yeah, he's able to turn it with his finger so far. Just shows the nuts are loose. Okay, right about here where he took to take it off. The nuts are off. I need you to see right there. Let me see. Someone taught me how to do the dot button. There we go. Come on. Don't rob myself. The anchor is an expansive shield. All right, so first let's look at the holes there. Aha, you remember that? Remember those holes? Remember what they look like right here? Well, that's what you're looking at right here. Huh, look at that. A nice, clean, sheared plane. Out here, it's not clean. Why is that? Well, because there are no this is where it gets a little raggedy at the very ends when you're shearing this material off. It gets like that. And so you see, but you get a cleaner looking shear between it, as you can see. So the last part is the forces between here, beautifully sheared between each other, sharing their loads, and the outer one fractures off. Well, it's all fractures, but it's a different shear, right? Different clean surface. And let's rotate these anchors around that he's going to show us. I'm looking at these anchors here. You see a clean surface here. Right there, I think I can get it. Remember, that's where I saw it. Right about there. He used an expansive shield, the person that did this before him. Well, I don't know if it was him before him, but it's an expansive shield. And what happens is you drive these anchors in, and then when you secure your bolt, your nut back here, it wedges upwards. And so it does create a force inside there that creates the same as that tapping effect. And the opening, closing again, a gate, nice little resonance, same as this guy tapping, tap, 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 tap. Well, ultimately, it accepts this accepts those forces. Take note of the air in here. There's a lot of air, a lot of voids, and very small pasty type concrete, meaning lacking of larger stones. So it's going to break even more friendly, and that's why stone breaks more friendly. They're consistent throughout the marble and all that, the size of the stone. So basically, you have the same thing going on here. There it is. Hold on, back up. All right, you guys see the expansive shield? You've seen those, right? So expansive shield bolts. Expansive shield bolts. I think it's called expanse. These guys. Nope, that's another one. That would be a different force. It would be more like that one. Right here. And there's your nut behind it. And as you tighten your nut, this comes forward, wedges itself between these two, and the force, it puts clamp force, clamp force at the outer base there against the wall there. This gets elongated, like tightening down the head of an engine. this becomes a long, clamping there. And the same thing with this guy. Does the same thing, the sleeved one. And uh, what trades off in materials, this with the cut in it wedges around with that bevel taper around this shield, but it moves forward a slight bit. So that is where the failure of this in this application is where the failure took place, I believe. The expansive shield. So instead of having your wedge at the top, instead of having your wedges at the top driving down, so the wedges are driving, instead of the wedges driving from the top down, let's see if we can get a close-up. Wedges driving, getting wider down here at the top down. It's just inverted. It's from the bottom up after the hole was created. And that is, so you take that in consideration when you're using these wedges. And you can see this one hasn't broken. It's got a lot more surface around it. These are closer to the edge. And you see it didn't break behind it. It broke the thinner edge up front. Remember, these have that force only has to break. So here's center line of that bolt, just what, an inch and a half or so inbound, right about from here to here in dimensions. So let's see what he's got for us. So we fast forward. He grabs this piece of steel that's beefed up even more, which drills holes. Yeah, this is sort of how I watch it. Drill holes. Oh, wait a minute. He's going to anchor this to the wall. What do you notice already? His holes appear to be in line with each other. When you bolt inwards, these holes are going to dissect each other. And now he's going to create the same issue. But this one won't be dissecting. This one probably, let's use a longer bolt. That doesn't make sense though, because since they're in line, this limits this anchor here to dissecting across this anchor. Same here. Now, I was going to write comments in there, but then I go down to the comments, and lo and behold, I noticed when you were laying out the holes in the anchor in the new piece of angle iron that you didn't offset them, and was wondering if you were going to have an issue with that install. So there is a major problem right there. And then we'll look at the anchors and we'll go to the video I have. So there's the bracket perfectly well. He could have just welded right to it. There's that wedge. But yet he's going to keep fabricating from scratch. So I find this, I would be quite upset to see this fabricated from scratch, especially when you can just simply done that. Plus use common sense, as this man stated. Oh, wait a minute, made a mistake here. At the point you notice they were dissecting, you're a welder, and I've seen him weld in the field, this guy. He could have put plugs in there, plugged it closed, called it a day, and removed the hole, and put the hole somewhere else. But that would have been sort of the right thing to do, and that didn't take place. I don't care about his amperage. I don't care about his comments on welding or his bracket comment. What we care about is the final install. So this is what it looks like. Beautiful table. That's that envy I told you about I have. Just that table. I priced it. I can't price that size. I went to buy the table today. Solid steel table. Yeah, two of them. Finally decided I'm going to pay this money for these two tables. And too late. Gone, both of them. I'll check again on Monday. Well, I got there at noon. They said it would close at noon. So look, right there. He's just using it as a template. Clearly, he could have just welded it right on there. Ground that down. Welded that together and called it a day. And line it up properly with the gate. I believe it's off center from the gate. Let's fast forward. I'm pressing 10 seconds fast forward. Okay, there we go. So there he's installing. He has this secured to the wall by what? I guess we didn't get to see that part. Oh, there's an anchor right here. So he drilled one hole, anchored it. So now he's going to anchor this one, dissecting this one, right? Let's see how far he goes in. Oh, wait a minute, he's talking about, isn't he? Hold on. For fairness.
And these things are amazing when you're attaching to concrete. Basically, you just drill it out.
I gotta go back 10 seconds. Shit. So I gotta press the play button
here.
These
things are amazing. 3.5-inch screw anchors from Hilti. And these things are amazing.
So he's using 3.5 inches. Clearly, that's going to dissect that one. All right.
When you're attaching to concrete, basically you just drill it out and you just drive these things in, and never will this thing come off. the wall.
Those are the anchors. I showed them. I made a couple of videos with these anchors by. So give it a little shout out to Bolt Depot. Why? Because Bolt Depot sends me bolts and things like that at no charge. It's for me to experiment with, etc. And I put a video up for them, as you see many times, as Bolt Depot. There we go.
Solid, strong connection.
All right, so you saw it pull in just a little bit.
And with 8 of those in there, bracket's never going to go anywhere.
This one's on an angle, obviously.
All right, there it is, all hooked up.
So he did it on an angle, and this one's on an angle, as you can see, a little bit of an angle, because he was dissecting his own product. It's still dissecting. So what? You got it on an angle. There's a cone of influence of clamp forces, but these anchors are nice for better than what his anchor was, and I'll show that in the part of the video.
Everything seems to be working good, and it's a big improvement from what they had before. This is a fun little project. I love doing these types of projects. I hope you guys enjoyed this video.
He doesn't show the gate out there, so
thanks for watching. We'll see you next week.
Okay, so people already got on about it. The only problem I see, you did not drill the holes in the new bracket. When you drill the holes, you should have not been aligned the holes, right? So he doesn't comment and address that and say, yep, you got me, good point. He doesn't do that here. And see, many days ago, he doesn't address his people saying, shit, good point. All right, now let's get rid of this video, and let's get rid of Expansive Shield bolts. No, we'll keep that one. And let's cut to my video.
Okay,
That's that Expansive Shield bolt. As you can see, this is a different company. It's they rust also. They are steel, and then they galvanize or zinc coat them. In this case, it's like a blue coating. As you can see here, it just created the wedge. The wedge effect still takes place. It needs to secure itself, and when it does that, it just still creates a wedge. And we're gonna see it here. This is 5 minutes and 48 seconds long, tying it all together. It's a gate issue for the Popeyes or whatever it is. I forget the store's name. Asked me to come look at their gate that was damaged by a car, and you'll see what goes on here. But it tied into the what we're talking about now. This sort of repair. Well, you can see first off, we've got already a repair here, and it appears to be on the surface of existing about 2 inches of concrete on an existing system that was out here. See, wood was out here wood at one time, and then they poured, maybe that was the pad there, and then these people poured a pad on top, maybe. It's definitely 2 pads. And then this was a corner repair.
Gate repair. So apparently they had to do a little blend. This is an anchor that a lot of people seem to think is a great anchor. You can see it.
Shit. Great. I wanted to pause it, and I pressed pause button, space bar, and it did that.
Okay, here's a gate repair.
Okay, that doesn't work.
So
you gotta use the mouse. Let's go from there. I'm gonna bounce this a little bit.
A lot of people seem to think it's a great anchor. You can see how it works.
All right, so there's the screw, right here, and you can see the blue lines where it turns into the concrete. Well, they anchor the drill hole. The drill diameter was less than that. These let's see, so it'd be crest. These crest surfaces, which appear as ref. So this would be the crest, and then it creates these crest over. That's the crest duplication on this side, which we would look at as the root on this one. All right, let's go. There we go. So that's what it looks like, and the pressure of that still caused a fracture. They drilled the hole down, and then they added a wedge. This is basically a wedge. I'm a fan of epoxy, guys, just so you know. If you want to do it, epoxy. It's not going to create that problem of creating a new pressure that's always existing there and working its way, waiting for vibration, closing the gate, wind rocking at this. All that acts as that little tapping thing. All that acts as that... Oh, it just popped away, that video. This one. It all acts as little tapping, all that little vibrations. Let's press play.
You drill the hole, it trades off a little bit of material right here. Trades off.
Sorry, this is they call this Popeyes. Asked me to look at this thing, see what's going on. Now, you see the other surface over here. Oh, it's Popeyes or something else, guys. I might have got the name wrong on that one. I think it's another one. I don't know. It's one of them. So obviously this was here. Had some rotation going on. This is where the anchor was. That anchor would belong back. Great. So this is a concrete mix. As you can see, a much stronger concrete mix with the stone, etc., than just a regular mortar mix. And I've seen the regular mortar mix, and I'll show that. I don't know if I already showed in the video. We'll be showing it. And obviously, I tie these two videos together. As you saw at the beginning of the video, I talk about the paste. It's also a patch, as you can see with the similar colors. It's also on top of something existing here. I wouldn't say it's an existing pad, but maybe it is an existing pad right there. There's a block stopping here. Okay, so then we need to resolve this for them. I'll show you the rest of it. It appears a car or vehicle has run into, this is a recycled oil drums that restaurants use, ran into the column somewhere about here, caused a reaction down there. So here, and reaction here, buckling the column, compressing it up here and back into the column, and that's why it's all broken like that. And that would be indicated somewhere on this, okay, inside that hole, inside that bracket. And there's your deflection. Well, it might be indicated in there because that bracket, that end of the pipe is pretty deflected weird for hitting a flat surface, but I'll know that Tuesday next week. Shit. Okay. There we go. On the top rail. So what can we do here? I can have them cut, since this is still pretty good in the ground. It doesn't show an indication of crack in the concrete. I'd say you can cut the pipe and go on top of this, weld back on top of this. Don't tear it all out. Just weld back on top. Cut it out here somewhere where it's straight again. Put a piece inside. Weld it back up. Its intent is just to hold the gate, so it's nothing that crazy about. Now this one on the other hand has got some cracking going around it where the gate possibly has been moved. Expansion water is getting over there. Let's see. Now it's got a cap on it. So maybe the drivers are being a little roughed on and give a few love taps now and then, and shake the pipe, and it gets back. It appears to be put back in place. All right. So they welded, and it looked like the fit and finish here. They welded the piece on here to make this go all the way down to here, and there it is, times 1, times 2, times 3 locations. The dimensions seem to be equal with the failed failed gate. So there is a crinkle. There's a major little break bust up. I don't know how it got the secondary break. Maybe they kept using it on the gate there, and then someone else finished it off with another hit, because that's another hit. That's another impact. This one, I don't think this piece is square anymore. Right here, you can play around with galvanized. You can heat it up, and of course, you don't mind a galvanic poisoning, if you will. If you look that up, galvanized can be quite poisonous, the fumes. So you really don't want to play with this too much. You'd rather just cut it and build another section here if this turns out to be flat. If not, just build the whole damn thing. Now, this is bent. This one is no longer plumb straight. So, what would you guys say? Well, I'd say scrap this fence here. Just grab the material, the inner material. That's pretty flexible. You're going to need another stretch bar, an 8-foot one, or two small ones to do the same effect. You can do that, a little bit of bridging across each other, won't hurt, no harm, no foul. So it's got to come out. The whole entire gate has got to fail. Now I'm going to show you a video. I don't know if I'll tie it into this one or not. Where we're going to be dealing with these anchors, and I've started to make the video, and then I said, you know what? The comments below, they seem like they nailed it pretty good. But I wanted to share with you guys now. I think I will make that video, and we should be talking about it in just a moment. Look at the anchors rust. These steel anchors are rusting. And that rusting ultimately will cause rust jacking, which would cause failure in the in its own design. So top rail also shot. So guys, I want you to take care. Happy New Year. But 2020, this is the 1-year anniversary of the fabricated virus. That's, when I say fabricated, because autopsies are not showing that people are dying primarily from COVID, that they have pre-existing. So this is the 1-year anniversary of that. So 2020 sucked balls, all of 2020, starting this December 31st. That was last year when they discovered the last day of 2019. And now 2021, at least somebody wrote on Twitter, as Doctor did, what are you happy about 2020? And I said, well, I'm happy it exposed the oligarchy. The oligarchy, you know, people who you know, the system's now been exposed that we're just subjects, that they don't care about us, we're subjects, and this big farmers program to get, you know, big pharma and everything else is running it, doctors and governors, and to hell with our whatever, you know, your civil liberties, etc. I'm adding that to the end of this video in case I delete it off, but the just wanted to show you. It appears that we got 2021 is what they call the Great Reset now, the time that these assholes are saying that. I don't look forward to any reset. I kind of like I miss our dysfunctional society the way it was. I don't like the dominance. All right. Take care, guys. Oh, and I'll just leave that alone. All right. Have fun. Bye.